Hello, everyone. Welcome to today's stream. I'm Wendy. I'm here with Edmar from your community team. We are joined today by the AECO Avengers. This is our third session discussing, we're going to talk about creating extensions for AECO workflows. If you've missed the first two, be sure to check them out. They are on our YouTube channel. Search for AECO, and they're really good. They're really, really good, guys. So don't miss them if you did. Make sure you catch up. But before we get started, we want to talk about. I know we want to talk about GTC.
It's coming.
So
It's literally 6 weeks away, I think. And Krista, I think, has prepared a little, or Michelle has prepared a little slide for Krista to go over.
Yeah. So GTC is right around the corner. It starts March 20th, and it's going to be a series of days with a lot of different talks. And this is kind of the curated list of things that might be super interesting for our AEC community. We're going to have a talk on automatic synthetic point generation, simulation in the cloud. This is going to be a great session with Nick Lork from Trimble and Spencer Huang from NVIDIA's own Isaac Sim team. There's going to be kind of a roundtable with a bunch of AECO industry leaders that are going to talk about the future of generative AI in architecture. And that's going to have some really awesome people from Autodesk, Heatherwick, Shop, Zaha, HOK, Fosters and Partners. So that's definitely a don't miss. If you don't want to get up at the 5 a.m. time to watch it, you can always watch the re-record. Then we've got Bentley. They're going to talk about infrastructure digital twins. Kevin Hart from Ariel is going to talk about how they're using immersive tech to build, design, and experience buildings in a better way. Eric Kraft from Mead and Hunt is going to talk about how they're using Omniverse as an open platform to enhance their workflows in practice. And of course, definitely don't miss the keynote from our CEO, Jensen Huang.
Who is that?
yeah, who's that guy?
Who is this guy? Yeah, that's a great overview. Yes, lots of great sessions. So it's really easy to register, everybody. It's 100% free, unless you're doing one of the very few sessions that's more workshop focused and there's hardware involved. But most of the sessions are 100% free, and it's all virtual, so it doesn't matter where you live. And it's as easy as going to nvidia.com/GTC. You can register, and then better to register sooner than later, because then you'll get updates along the way of content. But yeah, so we are excited to see you there. And as Wendy mentioned a few minutes ago in the warm-up, we will be having our user group there. And I think our user group is scheduled for the beginning of GTC. So probably shortly after the keynote, we'll be able to kind of maybe give a sneak peek at other stuff in the week to come. But we're going to be highlighting some user stories, partners, talk about the Omniverse roadmap. So it's going to be really, really eventful week for anyone following and excited about NVIDIA technology. So lots of Omniverse stuff there, of course. So let's dig in. As Wendy said, we have the Dream Team, Avenger Team. They have many nicknames, but they are all awesome. And as you saw, if you've seen the previous episodes of the series, they put a lot of work into preparing this material. Today is no exception. Robert is going to be going over some really exciting work, kind of showcasing stuff he's been working on just for the past months. This is stuff that he's putting all together so you can get to see what you can do and what's possible. And pretty much the sky's the limit. But before Robert, you get started, so you've already kind of met Krista really quick. And who's this other guy with the awesome background? Well, I guess there's two of them. So we'll start with the guy who's got the Jay. So Jay, what's your role on the team?
Hey, yep, my name's Jay Axe. I'm a product manager for AECO. I focus a lot on the visualization pipelines and really just getting content from the apps you use every day ingest into Omniverse.
Very cool. Thank you. And then the other amazing background, I guess, Cbot. I don't know how you did that, but it's pretty crazy looking how you got that little white background there. Can you want to tell me about your role in the team?
Yeah, I'm static there on camera. Yeah, I'm also a design platform specialist working on some of the products, very much in the AECO industry, and seeing where we can move this industry on a strategic level and also on an experience level further. So, yeah,
awesome. And of course, we have Robert. So Robert, tell us a little bit about your role here and what you're going to be showing off today.
Yeah, so I'm on the team with all the rest of these awesome people. I'm also one of the design platform specialists. I think like most of us, we're all come from the industry, practice architecture for a good 20 years. Spent a lot of time, in this role of like design, computation, and 3D, and coding, and I think architecture and coding is really becoming more kind of hand in glove, and I'm excited to kind of show what we're gonna show today. So, should
Awesome.
we get started?
Yeah, let's do it.
Awesome. I think my screen is up live, the
Yes.
video thing, right? Yeah. No, we can see my
Yes.
slide.
Yes.
All right, awesome. So what we're gonna I'm gonna take you through one of the connectors I was able to kind of make open source, and we'll kind of get to that in a bit. And it's Rhino Compute. And if you're in the AEC industry, you know and love Rhino and Grasshopper like all the rest of us. And what we're gonna kind of show today is just how beautifully Omniverse plays with it, and how Omniverse has the tool set and the systems in order to sort of really access all of the fun things that are available to you in that platform, so that you can bring it into our platform, and have them talk together. And I kind of titled this AECO Omniverse as a platform because I think a lot of times when we show you things, you see all of the pretty stuff, right? If you've been to any of Jay's talks, right, it's just filled with pretty stuff. Like, he does really good, pretty stuff. I'm showing you none of that today. I'm going to show you a lot of text. The text is going to have color, so it's a little bit pretty, but it's not as pretty as the images. But the point is that, Omniverse really at its core is this amazing platform. And by that, the ability for it to just connect and extend and consume and adapt and display not just geometry but data. And that's what we're going to talk a lot about today, because AEC is ripe with data. So I'll go to the next slide. The next what happened? There we go. Hello, next slide. There we go. You know these guys, you just got introduced to them. I'll just put their faces up. So now you can actually see what Cobus looks like. It's over here. Is that one? That's his actual face. It's very close to the cartoon face, though.
Very
So,
close.
it's very, very good representation. And Sebastian, who's now today. Excuse me. So I found this slide, and if you haven't seen it, it's on this site called bigdataconstruction.com. This is literally what the AEC industry looks like as a software platform.
Wow.
It is every kind of tool you could possibly imagine, from the big guys like Autodesk and Bentley and Nemcheck, to all the little guys, like littler, people in between. And this is what, a day in the life of an architect in AEC looks like. We have hundreds of tools and hundreds of platforms and hundreds of people, and they're all need to be connected together. And it's crazy. One of the things USD we know is solving is helping kind of unify a data structure in which we can do all of this amazing compute on top of, right? Because you have so many pieces when you think about a building, right? But that's what it kind of looks like. And understanding that, and where Omniverse kind of fits in, is that you're able to then tap into what these tools can do, because there's a lot of specialized tools that just do one thing and they do it really, really well, right? And you don't need to recreate that, right? But if you have 20 tools that do something really, really well, you want a home for all of these things to live in. And that's why the top of this slide says like welcome home, because that's where Omniverse really fits in, right? You know, we don't need to like recreate a lot of the stuff that's out there, because there's some very advanced things that do some really cool stuff, right? But what we do want is the ability to tap into that and have a single source of truth where all of that can live. And through the extension writing, and one of the things I'll show you, like a kind of nice example of that is kind of tapping into the Rhino compute ecosystem, in which we can kind of do some and pulling that into our ecosystem. And so for me, this is why having a platform like Omniverse is so important because it helps kind of make this home for all of our compute and all of our analysis and all of our design. And we can start using the extension system, which is really nice, by the way. Architects aren't traditionally coders, right? So everything we've learned was from YouTube and streams like this, right? So that's how we learned to code. So we know when something is easy and something is hard, right? Like if it's really too hard, it's probably not making it like into our industry. Like if you have to be like a 20-year C++, hardcore dev, like that's not an easy in for our industry. Python is an easy in, C Sharp is an easy in, right? Omniverse is actually a really beautiful platform to code on top of because the developers here spent a lot of time making it really good first class experience, putting things, where you expect them to be and making it nice. So, all right. Before we jump in, I am going to kind of go over some of the extensions I've written over my time here. Some of them are fun, some of them are like utilities, some of them but the whole point is that whenever you're in Omniverse, and it's like, oh, I wish it can do that. You're only a tiny extension away from it actually being able to do that. I'll also show you when I get into the live demo part that Omniverse itself really kind of I think the phrase is we eat our own dog food. But Omniverse is literally like when you open Create a pile of extensions, right? And so the same API that we have access to, you have access to, everybody else has access to, we consume the same thing, right? So when there's a button or a widget or a frame or a browser, it's all built on our extensions, right? And it's really cool. And I'll show you can actually see all the like what's behind the scenes. And so my team knows that there's buttons we want to do very specific things, and they're useful for us, right? They might not be useful for the larger, broader audience, and this is a very common thing in architecture, right? That a firm has a particular way about working, and the software company is not going to make like, oh, go ahead and make buttons that do exactly what I need them to do for me, right? That but what we're going to do instead is provide you with a really great platform to be able to do that. And so that like I create this thing called AECO utilities, which I'll kind of show later. It's just a bunch of buttons that just do things for our team to make things better. So one of them was like, if you ever played with Revit, the materials coming out of them maybe aren't the best if you haven't spent any time doing it. But the materials in Omniverse are really great. So one of the first ones I made was like a two-part thing, because again, it's really about data and pulling out data because there's so much data-rich stuff in here. So on the right, you'll see this little thing. It says write all materials to a file, right? So in this case, I had this file, and it was made up of actually multiple Revit files, but I just wanted a list of all of the materials inside of it. I'm gonna zoom a little bit forward. I wrote it. And I'm gonna pause here for a second. I wrote it inside the script editor, and I'll talk about this in the live demo though. There's a couple ins into how one writes inside of Omniverse. Script editor is like your first easy entry. It's built into Create and Code and a whole bunch of other things. It's a super easy way in without having to make fancy extensions and stuff like that. Although making extensions is also pretty easy. So it was just a very simple Python script, and all I had to do, was, and I'll show you how the UI works. And again, I just, told it to save it somewhere, and that's what it did. It just went and it wrote an Excel file with all the materials in there, right? So how is that useful? Well, I made a part 2. And so part 2 was read that and go ahead and write the materials. So part 2 says, oh wait, no, there we go. Here's part 2. Sorry. So part 2 basically says, okay, now I'm going to go in this Excel file and assign material. Now what makes this useful is a couple things. Why is... Oh, wait. No. Sorry, my screen keeps glitching. one, in architecture, not everybody knows how to use graphics software, but a lot of people know how to use Excel. Actually, everybody knows how to use Excel, right? So let's say you wanted to edit the materials of a file. All you have to do is open up Excel. Somebody just have to just go and reference the new name of the material. And in this case, right, so what happened was, again, so it's just a simple Python script and it reads it back. And in this case, it'll swap all of the material. I just made them all concrete just for, sake, right? It just goes back and it'll go read that Excel and then swap out every material in that table for concrete, right? So now instead of 100 materials in there, it's just one, and it's just concrete. And, a quick example of a very simple utility. Here's a fun one. So we also love Excel, right? When anybody asks me in architecture, what's the most important software you should know? And the answer is Excel. It really is it's like the glue. And in this case, actually, I like the sort of cloud version of Excel. This is Google Sheets. So I wrote a Google Sheets extension that live can Omniverse to Google Sheets. So you can actually manipulate geometry and data directly in Google Sheets, right? So here, another fun example of using Google Sheets. So actually, this was a test case for me too, to use our awesome thing called OmniGraph. So I wrote the Google Sheets integration as OmniGraph nodes. And so OmniGraph is like, for the AEC people, it's our version of Grasshopper. Or if you're a Houdini person, it's pretty much the same thing. It's node-based spaghetti graphs. So in this case, I have two new nodes, G Sheets that send prim data, G Sheets get prim data, right? So those are the two nodes I wrote. So basically, I find one node that's already existing, find all the prims, and you can see at the bottom, as soon as I plug it in, it went and it spit out the prim name and the prim path into the Google Sheets live, right? And then we can start to get things like properties, right? So I want to know the visibility property. So we can actually start to build this sheet in a parametric way. So I can get the visibility, and then I created a custom attribute on all my objects called my attribute, right? And then, basically I'm going to go ahead and I'm going to turn those two things into a list. Again, this is, so put 1, input 2, and then I pop that into my attribute list, and you can see it's going to go and query the visibility and the custom attribute and pop that into my Excel sheet. So what's really nice about this workflow is that because it's graph node based, I can build that Excel sheet however I want, including all the rotation data, the scale data, visibility, any custom attributes, and I can make a really robust connection. So now you see if I move that tree, if you watch the TY and TR values, they just live update as I move that thing around the screen, right? Because it's all live, it's all connected, and it's a nice little cloud-based solution, right? So really cool. And then here's the other way around. So in this case, I can go and right now all the cubes are stacked on top of each other. So I can just go and that's it. And it's going to go and move all my cubes in space. And I'm just literally editing Omniverse from a Excel sheet.
Nice.
Or in this case, it's actually Google Sheets, not Excel, but because I like Google Sheets, right? So cool. So that was another fun one. Okay. So this is the one I'm actually going to dive into today in the example before we get into it. I think I'm doing okay on time. So this is Rhino compute running inside of Omniverse. And so this is what we're going to do today. So we can basically run, I'm going to speed up a little bit. But, oh, nice. The video's inverted. So this is really great. You have to read the numbers backwards. I don't know what happened, but it's fun. We'll fix that later. Don't worry. But anyway, so basically what's happening is we're actually running we're taking this cube, we're sending it up to the cloud. The cloud is processing it and doing some cool processing stuff on the background. I'm pulling the results back from the cloud and putting it into Omniverse. So that's the server running on the right. That's taking all the commands. computing all of that on top of it, and giving me that geometry. So all that geometry is just being dynamically generated in a cloud computing app called Rhino Compute. So there's more, let's say, data-driven ones, which are really important. We kind of did this as a proof of concept for a customer. Basically, they wanted to create a dashboard and understand as they design costs, lighting levels, and a whole bunch of other things, right? So how do you do that? Okay, every time you drag something into, so first of all, we connected the prim, the thing, to a database. So when you clicked on it, it went and looked at a database and said, all right, what fixture are you? And it grabbed a little image of the fixture, and then told me about it. Its ID, its watts, its efficiency, its lumens, right? That data actually lives in a manufacturing database, right? Not in Omniverse. But what we do is we make that link, and this is that important kind of data connection, right? And where somebody who knows how to edit databases does their database thing, and somebody who knows how to design will do it in a design app. But now we link those worlds together, right? And then we went kind of one step further. It's like, okay, great, I can get all of this data, but what if I take it to the next level? So now I can do lighting calculations. And what it'll do is it'll go in my stage and it'll say, okay, how many fixture O1s do I have? All right, 31. How much does that cost? How much energy did that use? Okay. And so now, as the designer in real time starts to drag and drop different stuff right out of their asset library into Create, we now can see a live dashboard of, are you using more energy? Is it cost more money? How much, and so we can get metrics, and so we start to integrate this world of data and design, in this really nice little home. Make sense? Cool. So this is one of those ones I did for fun. So this is a house, and in it's completely solar. It's 100% solar. All the energy for the house comes from the sun. It's got a lot of sensors in it: temperature, humidity, all kinds of things. Right? Very semi-smart. No, they're not that smart, but smart enough. And I was like, okay, what if you can connect like live the solar inverter data directly into Omniverse, kind of like a digital twin. So, and I thought that it's not really a digital twin, but it's the idea of a digital twin. It's conceptually. So if you click on the solar panels, it'll automatically go and query in real time how much energy they're generating. Like this is like querying the actual thing in real time, right? There's no baked data here anywhere, right? And then if I click on the actual inverter, it'll give me all of the real-time streamed data from the inverter, right? That, in space though, which is really cool. So like, it's very graphic, right? Like, you can click on the actual inverter in its actual location in the garage and go get the data on top of it, right? And then, that was hooked up to an MDL shader. And so the more energy it generates, the brighter the yellow. So as it changes over the day, the shader keeps changing and adjusting over time. So I thought that, yeah. And then, and then I went one step further and I hooked it up to one of the sensors in, oh, it's not in here, but there's a little green sensor in there. And if you selected it, it would have told you the temperature and humidity. It's not in this video, but and so you can go pick any room and get its temperature and humidity value in real time.
So you just need to have those kind of devices just need to have an API.
Yep, exactly. So all those devices just need an API. And honestly, I have not really come across any as of today, that really don't, right? Like they all pretty much have some sort of API. There's actually a cool extension one of the lighting designers from one of the AEC firms did that's in the extension store that hooks Omniverse up to Philips Hue stuff, all the lighting. So in Omniverse, you can start changing the color of the digital light and it will physically change the color of the light that's in your place.
So cool.
Yeah. So they all pretty much have like these really great APIs to be able to attach and hook them up. Here's a video. This is the last video, I promise, and then we'll jump into the text, which is, I don't know, either more or less boring. But so you've seen this video a lot of times. You've shown it like 100 times. So the next slide, I'm going to just point out the important part of this video, but not it's all important. But there was a little moment where right here, where I dragged a panel off and it just magically showed me the apartment mix in real time inside of Omniverse, right? And so like it's this like 10-second clip inside of this larger clip that I think most people miss. And so I wanted to highlight it. This was an extension I wrote. And it's very much like the lighting extension. It goes and it counts stuff and it shows them graphically, right? So in this case, as the designer changes the apartment mix, basically this little dashboard just updates and gives you percentages of how many 2-bedrooms, how many 1-bedrooms, how many 3-bedroom type A's, and how many 3-bedroom type B's, right? And as fast as this is, like that kind of information is invaluable when you're designing, right? Because how do you know which one is the right one? So putting data in front of you to help you make those decisions is why we kind of want to integrate all of these pieces together, right? So that we don't design in a vacuum, right? And, aesthetics is important, but you need all of the metrics and data behind it to make informed decisions when it comes to which one is the better one. Especially when we start talking about energy and sustainability and all of that, right? We want all of that data. And Omniverse lets you hold all of that data. All right, cool. All right. So those are some of the fun little extensions I've built over my time here to help our team out. It's not even, that's maybe half of them, but those are some of the ones I wanted to highlight. So what we're going to go through today, though, is a little bit about getting started with Rhino Compute. It's that extension I showed you in kind of Grasshopper. So if you don't know, that one, it lives on Git. And that is maybe I can probably paste this in the chat somewhere. And I don't know if we can add it, but if you search, it's pretty simple. It's just rsavelioni-nv / it's the only one in that particular user for me, is the omni.rhino compute. And what this really is for those of you in AEC, you're very familiar with what Rhino is, and Grasshopper. And Rhino Compute is this awesome extension, basically, where Rhino itself, the program, runs headless in the cloud, right? So in a server somewhere. Now, the benefit of that is you can actually then spin up hundreds of instances of it and compute things in parallel and simultaneously and not on your computer. And you basically use it as a background geometry engine, right? So what we're going to do is I'm going to show you how that kind of works, kind of outline how to get it set up, how to clone it and things like that. And then we can start doing some modifications on top of it and kind of play with it and kind of go from there. So once you're here, I mean, the first thing, there's a whole bunch of ways to get in here. And the easiest way is to just clone the repo in your favorite cloning software. I use Git Desktop. It will clone it for you. If you don't know how to clone a repo and you're kind of new to all of this, you can, the way Omniverse extensions work, they're very, very simple. They don't care where they live, and I'm going to show you how to add it. So you can literally just go here and download the zip file and unzip it and stick it anywhere on your computer you like. You can stick it in my documents. It doesn't really matter. One of the things I really like about sort of the Omniverse ecosystem, although not best practice, but the extension can live anywhere you just point it to where a specific folder is. Really great for companies because they can stick all their extensions in a shared location and everybody can just point to that and they would get the extension. And if you're kind of new to this, it makes it kind of an easy lift. You don't have to have very specific locations. You don't have to install stuff. You literally just drop the folder somewhere and point to it. So just download it. And when you do, I'm looking for my code. Oh, there. Aha. When you do, you're going to get a bunch of folders. I'm going to actually open up the folder. I'm going to reveal that. There we go. Okay. You can get a folder, and it's going to say server.util.rhino compute. And there's going to be a bunch of stuff inside of there, and I'll talk about it later. I highly recommend as a dev platforms VS Code if you're not used to it. VS Code is fantastic. It's free and it's really wonderful. By the way, the first time I ever got into coding, I saw the word Visual Studio, right? And I was thinking, oh wow, there's gonna be cool graphics. No, the visual part just means that they make the text color. And so I was highly, highly upset about that. I was like, there's nothing visual about this color text. But that's the visual in Visual Studio, by the way. They color the text for you. So it was as an architect who deals with visual stuff all the time, I was expecting like, all right, visual, but it wasn't. So that's my little story about that. Okay, so once you've got it downloaded and you open it up in Visual Studio Code, you're gonna see something that looks like this. So if I roll it back up, you're gonna see there, there's that first folder, server.util.rhino compute. And in your tree, it's pretty much, a mirror map of what you see here, right? So, and then if you go one folder down, you're going to see EXTS. And if you go one folder down, you're going to see server config data, right? Server config data. It's just pretty much mirroring your folder structure. What we want to do is we want to open that up until we get to where we see the actual Python nodes. They're right here. Okay, so inside of that, if you go into server and then util and then that one, and then here you get the actual Python codes. There's 3 of them, and I'll go over the 3 of them in there. Also, the Grasshopper file that I have as a sample in here, I've also included in the repo so that you can just use it. So that if you download this, you can just do exactly what you see here. I've included the Grasshopper file that we're actually running, in the cloud. I'll show you what that kind of looks like in a second inside of Rhino. All right. So if you've made it to this part, what's really easy is the next part is like, how do I get this, to show up inside of Omniverse? All right. So the important thing about our extensions is this folder right here, EXTS. Okay. And whenever you have an extension, that's the folder we're going to point it to. So what I'm going to do is you're going to just go and you're literally going to copy the location of it all the way to the EXTS. You just copy. And then you open up your favorite flavor of Omniverse. So since we're encoding, naturally I opened up Omniverse code. But this works in Create, this works in Machinima, it doesn't matter. It's all pretty much the same extension system on the back end. So we're going to be in code, obviously, because we're, talking about code and all of those kinds of things. And code is just another flavor of Omniverse where you can just get all of these awesome tabs like already docked for you with all of your docs and all of these other cool things. So that's the only real difference. In Visual Studio, the debugger and stuff is already attached. So when you're in the extension browser, normally what you're used to doing is kind of like scrolling through here and turning stuff on, right? And off, right? This is your pre-built stuff. And then if you go to third party, which is where all your stuff is going to be, you know, you can turn off, you can go find all the stuff in the community. I love that we're at 76 at this point. I always check to see this number keep like going up and up as people put stuff in there. All kinds of cool tools inside of here, like the bookshelf generator, just in case you need to make bookshelves. It's actually really fun. Okay, but you don't need any of that. What you want to do is go to the little gear and click it, and it's going to open up this window. And all you have to do is, you can see I have it here, so I'm not going to redo it, but I'll do it over here, but I won't commit it, is you click the little plus button, and you just paste in that location up to EXTS. And then when you do that, I'm not going to commit that. I'm actually going to delete that blank line. But when you do that, what will happen is in your third party, now this kind of confuses people a little bit at first because they're used to going here, like all of our NVIDIA stuff, right? Anything that's not from NVIDIA shows up in this tab, and that includes user stuff. So you're used to the community tab, but anything you've developed yourself that is just local on your computer is going to show up in the user tab. All right. And so when you paste that address in there, what you should see is that Rhino compute for Omniverse show up. All right. And then you can turn it on. All right. I'm going to turn mine off and then on. Okay. And a window will pop up. Go back to the viewport. And so that is really the extension. Now, there's a lot of really great videos and tutorials and demos that show you how to kind of get started with this. I'll just mention it quickly for somebody who doesn't want to go through all the other videos. It's one of the things that made this super easy for me to jump into is that in that same extension tab, all the way to the other side, it's kind of hidden. I feel like this should be huge and like way more celebrated. Is this tiny little green plus button. If you click it, it will actually create all of the base files, code, structure, directory, everything you need to make an extension. And it'll save it on your computer. That's it. And literally nothing else you need to do. It'll even load it into the UI for you. It's pretty fantastic. It literally doesn't get any simpler than that. You just say, new extension template project. I'll do it. Why not? I think how am I doing on time? I gotta look at my phone. Yeah, I think I'm okay. No, I'm kind of running. Where I got like yeah, whatever. Anyway. Okay. But anyway, you just click that. It's fantastic, and I'm sure there's a lot of things on it, and it just will start up a new extension for you. And really, every single extension I have started from that template, and I pretty much didn't modify anything really. You know, you add a couple things to it, but you know, you don't modify much. So I just want to let you all know that that's where that exists, and that's how you kind of get started. All right, so let's look at what's happening here. We're going to kind of unpack it a little bit. So the base part of the extension is the UI part, right? And that uses a SDK called Omni.ui. And inside of code, one of the tabs is showing you Omni.ui. And it's everything you would expect in a UI. Buttons, sliders, fields, text, trees, color widgets, combo boxes, which I never understood. That's the drop down boxes. I don't know why I call them combo boxes, but check boxes, all of the things you would expect, right, to make a UI. And in this case, I'm only using literally two functions. One, under the arrangement one, so you arrange things in stacks, grids, or frames, right? I'm literally just using collapsible frame, and I'll show you the code for this, and buttons. That's it. That's the whole UI. I didn't make anything complicated here. And collapsible frames let you organize stuff, and buttons, well, we all know what buttons do, so they do that. you press them. Okay, so let's look at the code side of this. All right. This. All right, my code. So we're going to start with extension.python. So when you make the default template, extension.python is going to be the only file in your directory. And it's going to have some base UI code. And that base UI code is going to look something like this. I am going to shrink this because for this demo, the Omniverse part is less important than the text. So actually, everything I'm going to show you for right now is happening in this tiny little bar. So that's all you need to see on the Omniverse side. So you can see here, I just have this file open. And what we're going to look at is we have a window. We're calling that window Rhino compute functions. There's the name of it. And then inside that window, we have a frame. And then VStack, that just stands for vertical stack, and HStack stands for horizontal stack. So it's exactly how it sounds if you want to stack stuff horizontally or vertically, right? And then collapsible frame. So I'm going to stack my collapsible frames in a vertical stack. So you see a nice little vertical stack of collapsible frames. You have 1 collapsible frame, 2 collapsible frames, 3 collapsible frames. Each, and then we name them. Utility functions, so that's that 1 collapsible frame. Mesh functions, that's that collapsible frame. And Grasshopper functions, that's that collapsible frame. Simple. And then underneath those, we have a bunch of buttons, also stacked up vertically, right? Now, the cool thing about this code that I just really want to mention that I love as like a really great developer experience, if you've ever had to develop for some other apps, whenever you make code changes, you have to restart the program. And then, so you make a tiny change, you restart the program. You make a tiny change, you restart the program. Half your day is spent restarting the program. Omniverse hot swaps everything because it's reading the Python in real time and it's not compiled on the back end. Now, all that craziness talk just means that you type something, it updates. So, for instance, if you watch where it says Rhino compute functions, and I just call this my cool stream, and I press save, if it doesn't break, that now says my cool stream. Okay. It's that highly linked, right? So every time you make a change and press save, it will just reload the extension automatically. Hot swap. Which I think is pretty phenomenal as somebody who gets things wrong more often than right when it comes to coding. So the amount of times I have to press save and then it breaks and then press save again is pretty high. So if you're a coder who gets everything right the first time, it's not going to be a fun function for you. I would also like to meet you as a person if that's the case. So, okay. So, and then each of those buttons, again, are pretty simple. They have some basic commands on the back end. So, save it as a Rhino file, mesh functions. So this is where the part of extending Omniverse comes in. So Rhino has a whole lot of functions that Omniverse doesn't have right now in terms of geometry processing and things like that. So getting the volume of a mesh, or booleaning 2 meshes together, or quadrifying your mesh, which is really nice. So it like makes really neat, beautiful quads, or offsetting it. So you want to give it thickness, right? These are all, geometric operations that aren't, part of Omniverse, because Omniverse is really meant to kind of consume this kind of stuff right now, right? So by leveraging a compute engine like Rhino Compute, I now bring those functions into Omniverse, right? So now I can go in Omniverse and actually compute the volume of something, right? So let's take a look at, well, let me show you what that looks like, and then let's kind of unpack that for a second. So now I'm going to go like this. So I want to get to the Grasshopper heart. So if you don't have a Rhino compute server, I do want to make this kind of obvious for everybody. Inside of Rhino, and so this is Rhino and this is Grasshopper, right? Inside of Rhino, if you install something called hops, H-O-P-S, it will automatically, every time you start Grasshopper, start a Rhino compute server. So this is basically running as a compute server, as a local host on my computer, right? So if you're in a big firm or something like that, you probably have a compute server maybe running, in Azure or AWS or something like that, and you can connect to it. It's just, whatever. If you're just playing with it on your computer, all you have to do is install hops, and hops will automatically initiate a Rhino compute server. Nothing needed that happen on your end outside of that. And it's really great. And so I'll kind of keep this window off to the side right now. I'll actually put it on top of my code. And you'll see what's actually going to happen. So I'm going to go in here. I'm going to create some cubes. All right, there's some cubes. It's going to be a very complicated demo of cubes. Whenever you're doing live demo, cubes is the only way to go. Because it mostly won't work. So I'll make this cube bigger. I'll make this cube a little bit bigger. I'll make this cube smaller. Okay. And then those 3 cubes the same size. So grab those cubes, click volume. It sent that geometry to the Rhino compute server. And then it opened up a window and told me all the names of my cubes. And then the volumes of all of them. And then the percentage of the total volume that all of those cubes had. Right? So fun.
Pretty cool.
Why is volume calculation important? Well, if you've ever done a carbon calculator, you need to know the volume of the object, then you can multiply it by its CO2 per cubic volume, and you can create a carbon calculator. So then now you can take something like the volume calculations and turn it into a carbon calculator. So then if you're building, and you could, and I think making a carbon calculator is probably one of the best kind of entries into computing. Everybody has a carbon calculator. Everybody wants to make a carbon calculator. It starts with just calculating the volume of something and figuring out how much of that material is on it. So that's cool, right? So let's look at what's actually happening now in the background. Now, this way. Nope. Not that one. This one. Yay. Okay. So I have these things called Rhino compute functions. Now, this is my other favorite thing about the environment, the Omniverse coding environment. If anybody knows anything about the Python world, there is so many amazing modules out there, like all kinds of amazing things that people have written and let you have access to. And if you ever installed them, you typically do something called pip install. Okay, pip is a process installer, and it'll go and get cool packages. Well, Omniverse actually has a built-in way to hot load all of the packages in the correct directory, in the correct place, with one line of code. Right? So those, if you don't know what I'm about to say, then forget about it and just know that this exists, and it's the most amazing thing. If you do know what I'm about to say, you'll know why this is amazing. Is that previously you'd have to set up a conda environment, and then you set up this different weird environment, and you pip install your packages into the environment, and then you point your compiler to that environment, and great. And then you're holding all these different conda environments to be able to. Here, we can forget about all that. We just do omni.kit.pipapi.install, and then that's it. And then the other cool thing is now every time you turn this thing on, it's going to go check and say, oh yeah, wait, that API got updated, and it's going to download the new one. For better or for worse, that might do some breaking changes, but it does it. So there's 3 things I'm installing into this kit. The Rhino, the base Rhino library, the Rhino compute library, and then the thing that made that pretty graph is one of my favorite extensions called Plotly. If you haven't used Plotly before, definitely. It makes like bar graphs and and pie charts, and I love graphing data, so it's I'm gonna if you haven't, go geek out on it. It's awesome. You can do all kinds of amazing graphing functions and dashboarding and data with Plotly. And to install it, all I had to do was omni.kit pip install Plotly, and then I told it a specific version I wanted to use, and it holds on that version. So if you didn't want it to always get the latest version, you just do this, and it will just ignore any of the new versions and just make sure that one's installed. The other nice thing about this is if you've ever given an extension to somebody, they have to go then do all of this crazy conda stuff for your Python thing to run. That's not the case here, because all somebody has to do is when they go and enable that extension, it will go and install the stuff it needs to install in the background automatically. Right? It's amazing. I love it. It's one of the nicest features of this. So it just auto installs all of your required packages automatically in the background for you. It's really, really nice. And it happens the minute you go into the extension manager and click that flag, and you turn it on, and it goes and it'll trigger all of the install for you. Super nice, amazing. I love it. All right, so let's go down to the actual function that's happening. Mesh volume, right? So first of all, we need the URL of where the server is running, okay? And again, if it's a local host, you'll find that actually in the at the top of the extension, by the way. So it's just localhost port 650. That's the kind of if you're running it local, that's what it is in this window. If I scroll all the way to the top, it says it right here when you start up your Rhino compute server. It spits out its address so that you know what it is. It's localhost 650. If this was running on an actual server somewhere, it would be HTTP that myrhino compute server /6. It's probably 6500 unless somebody made a custom thing. So that's simple. Okay. So where is the Rhino compute server? And then we take all the selected meshes. And so this is another function I'll jump to in a second. And a lot of what this thing is meant to show you is not only the power of like connecting to stuff, but how easy it is to go from your native geometry to USD and USD back to your native geometry. In this case, we have to take USD mesh, turn it into a Rhino mesh, compute it on the Rhino mesh, put it back to USD. And that back and forth is actually incredibly straightforward and really, really easy. And so that's one of the main reasons the sample exists, is for the AEC community to show you how easy it is to go from, X geometry to Y geometry, because especially when it comes to meshes, they're all faces, verts, and indexes, right? It's just you make one face array, another face array, and it's that simple. Okay. So then for all the meshes that we have selected, it's literally this one line: compute that Rhino 3D that mesh that volume. Great. We go give it the mesh, we get its volume, and then we figure out its name. And then this is the Plotly part. So, go.py, you can change that to, any kind of chart you like. Instead of, want a pie chart, you want a bar chart, whatever. We label it and we give it the volumes. So this part here, so you can see it's I don't know what, 10 lines of code. Very simple, right? Now this part's a little bit more. I'll kind of let me kind of roll that up. I have that in the utility section. So the utility section is the two main features: convert from USD to Rhino. So USD mesh to Rhino mesh, and Rhino mesh to USD mesh, right? So in this particular instance, everything we do, we just keep going back and forth from a Rhino mesh to USD, USD back to Rhino, back and forth, right? And it's very straightforward. You have a list of vertices, faces, and points. You get its X form in space. You create the Rhino mesh. You get the points that make up the mesh as points, known as vertices. You get the faces. You get something called face counts. You make the faces. You compute the normals. Return the mesh. All right. I'm not going to dive too deep into this, but if if you're into the into APIs and using Rhino, this is all going to be very, very familiar to you, and you're going to see that the important point to outline here is you're going to see that the overhead of like going back and forth is pretty seamless, and most of the stuff you're used to working with is very, very similar in the USD world. Normals, spaces, verts, points, indices, they're all, it's a very similar data structure. And so you're going to feel very comfortable moving your data around from one to the other. And the API into it is actually very well done and very robust, right? You got to remember, Pixar has been using this for over a decade at this point, and it's pretty battle tested. It's robust. It's really well done. It's a really nice set of their mesh class is just really nice. And then to go back, it's the same thing in reverse, right? Then we take the Rhino points and we turn them into USD points, and Rhino faces turn them into USD faces. It's literally the same thing in reverse. Okay, so that's how like one of those simple functions work, and you can see in my utility here, no, not this one. Sorry, this one. I have a whole bunch of them. So mesh volume, mesh boolean, quad remesh, right? They're all pretty simple and they all follow the exact same thing. Get the compute URL, convert the USD into a Rhino mesh. Go ahead and compute that function, right? Compute that quad remesh, and then spit it back out into USD, right? So I'll show you that one, and then I'll jump into the Grasshopper one, and we'll open it up for questions after that. So in that particular case, although when you're, I'm not a fan of this new shade bar. So I'm going to go to wireframe because quad remeshing something, you need to see the wire. So you can see our mesh is a weirdly triangulated mesh. It's not weird. It's just a triangulated mesh. Maybe weird's not the right word, but it's triangulated. But let's say you want a nice, neat quad. You can just do this, quad remesh, and voila. Quad remeshed, beautiful mesh.
Awesome.
So the original and the quad remesh. Right, so now everything's nice. It only shows in triangles because of wireframe, but it's actually quads. The triangles aren't real. And so that's it. And you get the quad remesh. All right. Now the one I think everybody is going to really love. It's the Grasshopper script. So if you've ever seen a Grasshopper script, it does a whole lot of compute in a large spaghetti graph. It looks very much like our node graph system. So I'm going to show you what's actually happening. So, and this is the nice thing, like not everybody is a Grasshopper person. So this is the script. And so, Grasshopper, right? So we take poly, I explode it. I do a whole bunch of stuff on top of it. I create diamonds, on the face. I remesh those diamonds. I do a whole bunch of compute, right? On top of that, right? But I'm going to close this because this does not have to be opened. You don't even need Rhino opened, right? So Rhino does not have to be opened in any way, shape, or form. I just wanted to show you this script. So Here I went kind of one step further, which I thought was really neat. Is I'm going to make this box bigger because I just know scale-wise I need to do that. Okay. So now I can go in here and click the random diamonds ones. But now I have a sub UI. So I have 4 sliders. All right. And what's really neat is I actually don't need this cube visible. So I'll actually keep it visible for the first one. I'm going to click run. And I'm going to hide this cube. And you can see it generated the diamonds. Okay. Now, what's really cool though is because, is that cube 4? Yeah. Because this is live streaming to this server, I should probably turn some lights on. Yeah. I'm going to go with Gray Studio. Probably turn some lights on. Wait, where did they go? Uh-oh. Oh, there they are. Oh, I accidentally selected the wrong cube. My bad. Where's the cube I was supposed to select? Was it this one? Oh yeah, this one. Sorry. Better. Okay. I'm gonna hide this cube again. So you can see as I change this number, it's actually changing how many divisions are on there. So I'm generating thousands of thing. I'm gonna give that a nice material so we can see. I don't know. Let's see. I don't know. Do aluminum. Fine. Yeah. But I'm gonna second. Okay. That's weird. That should have let me add a material on it. Oh, there we go. No. Okay, whatever. I'll just add it at the lower level. That's a weird thing I have to check out because it should have let me add that material at the group level. Is it kind of a little small? There we go. Better. Now you can see them better. So those are all those like like little diamonds, right? Like, and what's nice about that is like we can make this very complicated. It's generating so much geometry for me, on the fly, which I think is really, 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 really nice. I'm gonna delete it for a second, and I think it's Q2. Yeah, it's Q2. And you can change the maximum in and out. I'm actually generating a lot of them at once. Anyway, so what we're doing is basically we're obfuscating Grasshopper to an end user. And this is kind of where I want to kind of end this kind of little tutorial, is that one of the things I know that, is a little bit harder in the architecture world is to take some of the advanced tools like Grasshopper and do something we like to call is democratize those tools, right? So in a firm of, 1,000, there might be only 30, 40 people who know how to really work their way around Grasshopper. But if we can use a platform like Omniverse to take all of those tools and wrap them into simple UIs and buttons that sit inside of an interface that's one layer abstracted from the sort of compute side of things, the Grasshopper side of things, all of that, and just make it very easy for the user to interact with, then it doesn't really matter, the complex what's happening in the background. And then additionally is if there's a bunch of functions in a Rhino compute server that are great and a bunch of functions in another type of system that are great, Omniverse can become that home where a single set of functions can live in one UI, but it might be accessing 4 or 5 different things in the background, right? And when we obfuscate that kind of level, then we make it easier for the user, right? So that, there might be another button that just does some energy analysis and it has to go and query a completely different system. But that's okay, because to the user, they just see an interface, some sliders, and some buttons that just bring all of those pieces together in one unified environment. And I think really that's like something I'm very excited about, like Omniverse, especially for the AEC to do, because if you go back to that initial chart where there's 45,000 things, right? If we don't have to go to 45,000 pieces of software and we can start to stitch together the useful things into a single interface, then I think we're really going to then get somewhere. So I will leave it for questions from here or comments or, that kind
I
of thing.
think generally it's pretty amazing. I loved seeing how this, this workflow impacts real world kind of questions and problems and challenges. I think a lot of people are very wowed by your interactive, dynamic show and tell house. But yeah, I think this is, and I think this is a great way to go over all the possibilities. It seems like there are no ends to the possibilities. Um, so we got a few comments, basically just saying, "Wow, this is the future." Very interesting to see in real time like this. Um, very, very interesting to see how the live demo did not crash.
Yes,
Did it
I was
crash?
also
success.
excited about that. I was very much also excited about that. Yes.
Yeah, that's funny. That's from Rian. So thanks,
Running on dev stuff.
Rian.
I think just to add, Emma, I mean, Robert mentioned it very well there, and the opening picture was absolutely amazing, showing the complexity of software. But
Yeah.
but what we love to tell people as well, I mean, we love Rhino compute since they released and so forth. But we tell people now, well, you can run Rhino compute on Rhino geometry, right? And they go, yeah. I says, well, you can run it on Revit geometry, right? Yeah, we can use Rhino inside on Revit. We can run it. And I go, well, can you run it on SketchUp geometry? And can you run it on ArchiCAD geometry? And can you run it on Unreal geometry at the same time? And they go, no. I said, yeah, you can. Just bring it into Omniverse and run it from Omniverse because it's
It doesn't
agnostic and
matter.
open.
Exactly.
It doesn't matter.
Exactly. It doesn't matter where the cube came from or the wall came from. Like, who right? Now you can run your Grasshopper script on anything.
Awesome.
Yeah, I
Very
think
cool.
it summed it up when Robert said a single source to kind of, mesh the collective together into a single source. I think that's awesome.
And to the point that you go from here to the application that does the best job for it and you bring it back in again.
Right.
Yep.
Yeah.
And in this demo, I'm like manually rotating and scaling that cube, right? But the reality is in an architecture workflow, somebody who's like modeling in SketchUp or in Revit moved that wall, then that wall gets updated in here and you can just update the script that went and panelized that wall, right? Like, the fact, if this change came downstream from Revit because we can connect that, right? And now the wall looks like this, it's like, okay, great. Rerun the thing and there it is. Now the wall is now the, like if I had the wall, it's there. Right. And so you can start to connect all of these pieces together and it's pretty phenomenal.
Yesterday
It's,
we had Mark Thomas on from Nextbase. I don't know if Robert or you folks have worked with Nextbase at all. We had Michael Clive
Yeah.
on from the
Yeah,
Omniverse
we know
team.
them. Yeah.
Yeah,
Yep.
but really that was super compelling. Basically showing how all data that you wouldn't think would be able to talk to each other or be visible from different points was like, oh my gosh. So that I think that really did blow a lot of people away also. Because I think people are very used to all this data being siloed in their own applications and not really, but being able to see how you wouldn't think these two things would be able to talk or be visualized to one another. That is, that I feel like that's what this is all about. And so it definitely feels like a dawn of a new day for this data interoperability.
Agreed.
Very
I think Nextbase is a good example because, system, right? Like it's so data rich on the back end, right? And then you then pair that with, the, ability of Omniverse to be able to aggregate all that data and then house it from multiple sources and then access all of the data rich stuff on the back end, and then extending that into dashboards and live data analysis, right? Like that's really kind of the exciting part for me about where like Omniverse can really take things, you know. It definitely always also makes it look pretty, but you know, it's just such a great platform for all of our data rich geometry.
Yeah,
Someone had asked
exactly.
earlier in the chat about NPCs or bots. So obviously that's probably more of the question for the Isaac team, I think. But do you normally
Focus is an
work with any
NPC.
kind of extensions that are using kind of bots in your architectural planning?
So there is some I don't know about bots, but maybe like AI, is that what they're more
Yeah, I think
referring
so.
to?
I think like they're talking about like NPCs like walking around,
Oh
maybe
yeah,
to
I mean,
simulate, wheel movement.
so that is something we're having deep discussions about, is how to not just get game level movement into our software. And again, it ties very closely to this discussion about there's tools out there in the architecture industry that are brilliant at that, right? That can understand people movement. Like there's two really big ones out there. Um, and they're scientifically accurate. They can figure out how people move through airports and train stations, right? And but they're locked up in these very highly scientific world. They don't have great visuals. A lot of times they don't make the impact they're supposed to have because they're so hard to integrate into the design process, right? And then you start feeding that data into something like Omniverse, and now it can make a meaningful impact at the design for the design of the thing. Yeah. And that's what we hope all of these tools do. Is the closer we get them down to source, down to truth, the more likely they are to have a real impact, right? And that's, you know, if it takes 7 days to get the geometry out of what you're designing in and then go do an energy analysis of it, the design has changed in 7 days. And so what you learn from it is meaningless, right? Because, you know, now you got to do it again, but you don't have another 7 days to wait. So a lot of times the sad part is like, you know, they end up where I think I've talked about this. It's called appendix architecture, right? Like you're done designing and then you know you need those graphics in the back of the report. So you go and you do it and you run the analysis and get the pretty graphics and you understand how your building worked, but it made no impact on the design. It's just like, oh, all right, we'll know for next time. But if that data was up front, it might have actually changed what it looked like, you know, and that's where we hope that like being able to collate it in a platform like Omniverse that we can actually make meaningful change.
Yeah,
Well
well
said.
said. Yeah.
So for anyone who's kind of tuning in and this might feel a little bit overwhelming or new, there's great documentation and tutorials available, not only in this series, of which this is part 3, but also in other videos we have produced internally for the AECO. So those are available on the YouTube channel, also on NVIDIA On Demand. So just do a search for either one of those two, and you'll see some nice playlists. If you like, you're welcome to come to our Discord. We actually have an AECO channel where these folks are actively involved, so you can talk to us directly there, as well as the other members in the community who are using this tech. So, really happy to welcome people there and share resources. We can share links for things more directly on Discord. Of course, if you're having a problem getting started, feel free to head over to the forums. Where Wendy helps make sure our development team can help people quickly with any technical issues they may be having. So, Jay, Cbot, Krista, anything else that Robert may have left out of that very intense, deep dive into Python? It wasn't really very intense. It was fun, but yeah. Anything you want to part the stream with?
Just reiterate that the Google Sheets part is super cool, and I'm gonna start diving in because I'm come from the visualization end, so this is all new to me as well. But I'm gonna go for the G Sheets route, and I'm gonna start connecting that into my projects for Omniverse. So I'm excited to dive in with everyone else.
That's very cool. Maybe we could follow
How
your progress on that then. We'll check in with you. And Krista and Seabot?
Yeah, just that it's super awesome to be on Robert's team because we all love Omniverse, but then he can do all these custom things and really harness the power of the platform, which is awesome.
and all I can say is, how about that house, right? Real time. And I know that
Yeah.
house was designed in a BIM piece of software for construction purposes, and now it's being managed in the same software, which is awesome.
That is wild. Yeah, true digital twin, but really cool that you can. It's
It's super
dynamic and live. It's really insane. I can imagine there'll be a lot of companies who love to be able to fool around with that kind of workflow. It really seems like a great way to plan, but also to build and expand. So very cool. Well, I got to thank everybody for joining us. So do you have the next topic ironed out? Is there going to be a number 4 of the AECO series we're doing?
Nothing right out yet, but we're definitely open to suggestions. So if the community has anything they want us to talk about, send them my way. And if not, we will make an announcement soon about what that next topic will be and when that date is.
Okay, that sounds great. So again, everyone should be welcome to the Discord server, discord.gg/NVIDIA Omniverse. And then we have a channel there called AECO, where you can chat with these folks, as well as Wendy, myself, and we'll help with any resources you might need. Thanks again to everybody. Thanks for the viewers, thanks for the comments and questions. I really appreciate it. But thank you to the AECO team for putting so much thought and time into
Yes.
this series. These presentations have just been amazing. A great wealth of information, so really helpful and really excited to what you guys show and tell next. So next week on the stream we have we're going to do something really cool, Blender and audio to face. I don't know how much that interests the AECO crowd, but for everyone else out there in the world, it's pretty neat. We're going to show off some really cool stuff that's been happening with Blender and audio face lately. And obviously, the other part of digital twins is avatars and virtual avatars, and there's a lot of really crazy tech that is just mind-blowing now, how quickly things have evolved, and just in the last several months, I have to say. So really cool. We're going to show off the latest and greatest next week live stream. We're going to show and tell some really nice workflow. So that's next week. You can check our add event calendar. It's posted on our Discord and in the chat from earlier. That shows all of our upcoming live streams, and you can add them to your calendar really quickly. Until next time, thank you all for joining us. Thank you, Wendy, for doing such a great job as always on the hardware and layout.
Yeah, it worked today.
It did work today. Yesterday we had a little bit of technical problem, but that I think had to do with we were starting a stream when one was just ending, and as Wendy said, the streams got crossed.
We crossed the streams.
The router got all confused, but anyway, I think we got that figured out. So thanks everybody, really appreciate it. Have a great rest of the day. We'll see you on forums and on Discord.
Bye.
Thanks everyone.
guys.
Bye.